Hey folks, this is the sixth video in the video series, and in this video we will be talking about HTTP and HTTPS. In my previous video, that is the fifth episode in the series, we spoke about TLS, and that is like a very important prerequisite when we talk about HTTPS in this particular video. So I highly recommend you to watch that video before you come to this video, and then we can proceed with this particular video. Okay, so if you ask me what is HTTP, I would just tell in a layman's language it is a normal protocol which is used between a server and a client. Okay, so whenever a client wants to talk to a server, it uses the HTTP or HTTPS protocol. It is just a set of rules through which both the client and the server know how to communicate with each other. Okay, so without further ado, let's directly jump on to the demo that I have got here. So here we have got a very simple packet capture. What I did was I just ran Wireshark when I visited wireshark.com. Okay, and this is the kind of packet capture that we got. Okay, and the filter that I'm applying here is to just filter for the IP of wireshark.com. Okay, so then if you notice, we again have our SYN ACK and the ACK packets here initially for the TCP handshake. Okay, and once that is completed, what our browser does is it creates a HTTP request. Okay, so we are talking about two things here, HTTP request and HTTP response. So the request is ideally made by a client which wants to access the website, and the response is given from the server. Okay, so if we look at if we expand the request here, the HTTP request, oops, sorry, this is the HTTP request, yeah. So if we expand the HTTP request, what we see is there is something called as get here, right? Okay, so this is the method that the client uses to query for a particular resource. Okay, and it is querying for slash, which is the first page that has to be served. Okay, and it is talking, it is making a request to wireshark.com. Okay, and if you see at the end of every line there is /r/n, which just means carriage return. It is just to differentiate between multiple lines in a particular packet. Okay, the next header that we talk about here is user agent. The user agent basically tells the server what application or what a browser is trying to make the request. Okay, in our case we are trying to make a request from Mozilla Firefox here, and similarly if you just use curl from terminal, you will see that user agent, and you can easily manipulate this as this is what the client is sending. Okay, the next thing is accept header here. What this talks about is what all the client is ready to accept in terms of response. So the server will be sending a resource or some details as a response, right, in the body. So this is the formats that the client is ready to accept. It is ready to talk in HTML, XHTML, XML, etc. Okay, similarly, if we look at the next header, accept language, it talks about the kind of language that the browser prefers. Okay, here we are talking about ENUS, which is the US English. The next header here is accept encoding, and we are ready to accept gzip and deflate. Okay, the next header is DNT, which is specific to my browser. You might not see this if you try this out on your browser. This basically means do not track, and I've set it to 1, which is true. So the server respects this and will not track my connection. Okay, the next header is connection keep alive. This means that I want to keep the TCP connection which is established alive for some time for subsequent requests and responses. Okay, I do not want to close the connection right away after I get the response from the server. The last header that we are talking about here is upgrade insecure request. Okay, this means the client is ready to talk in much more secure requests. The request it has sent here is HTTP, if you can see here, hypertext transfer protocol. We are ready to talk in a much more secure request format, for example HTTPS in our case. Okay, so this is what the client is sending in its request. Similarly, if I go to the response, we can see the HTTP response here from the server. Okay, so the first thing that we notice here is it is sending a HTTP 302 not found. Okay, this means it is a redirect, if you remember in our previous videos. Okay, so basically the server is trying to redirect us to another website or another web page basically. Okay, so if you see here, the location is what matters for us here. It is trying to redirect us to https://wireshark.com /index.php. Okay, so this is the website it is trying to redirect us to. Just notice the HTTPS here. This is also because we set the header to accept or to upgrade our insecure request. Okay, so this is about the 302 found. Once the redirection is sent, we also have something called as keep alive. The client had sent the connection keep alive header. The server respected it and it set a timeout to be 5 and max 100. Okay, so here timeout 5 means the server is going to keep the connection alive for the next 5 seconds, and max 100 means in those 5 seconds the client can make a maximum of 100 requests to the server. So this is about keep alive, and then we have content type. This is the content type response which the server is sending to the client. Here when it tells text/html, all the body that the server is sending to the client is in HTML format. Okay. Then we have the file data size, which is 217 bytes for this particular text HTML section. Let me minimize this. Okay, so this is the data which it's sending. So basically this gets rendered on our web page, and it tells 302 found, and it redirects us to https://wireshark.com. This happens in like milliseconds or something. That's the reason you never get to see these kind of redirect requests. So once I get the response from the server, and it redirects me to HTTPS, the next thing that happens is the TLS handshake. Okay, and this was clearly covered in the previous video, so you should definitely check it out if you want to know more about how a TLS handshake works. So you can see that it has started with a client hello. The first thing it does is also establishes a new TCP connection first. Okay, so a new TCP three-way handshake is done. Then we have client hello, then we have server hello, then certificates are exchanged, then we have server key exchange, and then there is client key exchange, and finally application data. Okay, so if you notice here, Wireshark is telling you that this is TLS version 1.2, and this is the application data which is being sent, but it is not telling you it is on HTTPS. So if you notice here, we clearly got this particular packet in HTTP, but the data that it is sending is not in HTTPS. This is because Wireshark doesn't really understand the encryption. So basically, HTTP and HTTPS work on the application layer, and the TLS basically encrypts the entire packet and then it pushes it below to the below layers, right? So by the time Wireshark captures these packets, it does not really get to know if it is HTTPS. So it just marks it as TLS v1.2, and we cannot read this application data, the Wireshark's web page, basically because it is encrypted in TLS. Okay, and there is no way for us to decrypt it unless we go ahead and use the key, the symmetric key that was initiated during the handshake. So this is how the HTTPS works. So another thing which is also important is the request methods. Okay, so the example that we saw had a get method in it. Okay, and the get method is basically used to request for a web page, for a particular web page. Okay, we also have other methods here. The first 5 methods are kind of important. The head method is used to request for the page's header. Okay, so instead of giving me the entire body and all of that, I can just request for a head method, and the server will just send me the header in response. Okay, so the put method here is used to basically put a resource on the server, resource or a file onto the server. So you can basically send a file and it will put it to the server. If there is no file existing in that particular path, it will create one. If it already exists, it will replace the file. The next method we have here is post. So basically in a post request, you send data to the server. This data has to be rendered and used by the server to make sense and to put it on the server, and then it sends a response to the client. Okay, so basically on a post request, a server will have to trigger some kind of mechanism on its side to basically render the particular request and then send out a response. It not necessarily has to create a file on its server. Then the last method we are looking at here is the delete method. This is used to basically delete a particular resource. It can be a web page or any other resource from the particular server. Then we also have The response types, the one we saw belonged to 3xx, which was a redirection. I have like a generic method to define the various types of responses that we can get. So basically 1xx stands for anything with xx replaced by any digit from 0 to 9. Okay. And basically anything which is 1xx is a informational message. So the server can just send some kinds of information to the client which is requesting for it. Then 2xx are the kind of responses where the request is a successful one. The response is basically something that the client can rely upon. Okay, these are successful responses. 3xx are the redirection responses that we have seen. Then we have 4xx, which are problems on the request which the client generated. The request which the client sent had some problems in it, and that's why the server responds with a 4xx. And 5xx is something that is a problem on the server side. Okay, when the server is not able to send a proper response due to some error on its side is when it responds with a 5xx. So these are all the response codes. Now moving back to the capture, I also forgot to mention that let's say you visit wireshark.com and it has an image which is coming from say google.com. Okay, so to fetch the image from google.com, your browser goes through all of these steps again. Okay, it basically tries to resolve the domain name of google.com. It creates a TCP three-way handshake, creates a socket. If it is over HTTPS, it goes over TLS handshake and all of that. And then finally it is able to get the image. Okay, and once that is done, it is displayed on your browser. So that is all I had for this video. So stay tuned for the next video, which is coming up on how the web page gets rendered on your browser. Thanks for watching and see you next week.